preparation of alkanes. I will teach you the super easy way to master preparation of alkanes. Using these three methods, we can easily prepare any desired alkane. Now the first method to prepare alkanes from alkyl halides is Wurtz reaction. I call it couple making reaction because it joins two alkyl halides of same mindset to form a beautiful couple. Remember that we use Wurtz reaction to form some alkanes, are alkanes having even numbers of carbon, butane, hexane, etc. For example, consider this methyl chloride and this methyl chloride. Let this is a handsome boy and this is a beautiful girl. Here comes sodium baba and it acts as a matchmaker. It gives electron to this chlorine and electron to this chlorine. As a result of this, sodium chloride is formed. Now the handsome boy and this beautiful girl marry to form a couple. I mean, they form ethane. This Wurtz reaction is used to form symmetrical alkane. Now let's make butane and hexane using Wurtz reaction. We know that there are 4 carbons present in butane. So I take one ethyl chloride and another ethyl chloride. Secondly, I take sodium and dry ether. This sodium will provide electron to this chlorine and to this chlorine. As a result, we get sodium chloride. Now this ethyl and this ethyl combine together to form a butane are a beautiful couple. Remember that we take dry ether in order to provide safe medium to sodium because sodium violently reacts with water. Thus we use 2 ethyl chlorides in presence of sodium and dry ether to make a butane. Now in case of hexane, we know that there are 6 carbons present in a hexane. So I take one propyl chloride and another propyl chloride. Secondly, I take sodium and dry ether. This sodium will provide electron to this chlorine and to this chlorine to form sodium chloride. Now this propyl and this propyl combine together to form a hexane are a beautiful couple. Thus we use 2 propyl chlorides in presence of sodium and dry ether to make a hexane. Now let me teach you one important question. Why we do not use Wurtz reaction to form unsymmetrical alkanes? Well, we do not use Wurtz reaction to form unsymmetrical alkanes because it produces a mixture of many products like unsymmetrical alkanes and cross-coupled alkanes. It is hard to separate the unsymmetrical alkane from the mixture. Therefore, we do not use Wurtz reaction to form unsymmetrical alkanes. To make unsymmetrical alkanes, we use Corey-House reaction. So the second method to prepare alkanes from alkyl halides is Corey-House reaction. Remember that I do not say Corey-House reaction, I always say Cooley. 9.2 crore jobs will be displaced by 2030 because of AI. I just got my hands on the Future of Jobs report 2025. Cooley-House reaction. Let me repeat it. I do not say Corey-House reaction. I always say Cooley-House reaction. This C always reminds me copper iodide and this L always reminds me lithium. So in Corey-House reaction, we use 2 things, lithium and copper iodide. We already learned that we use Corey-House reaction to prepare unsymmetrical alkanes using Corey-House reaction, or I call Verath-Cooley reaction. First of all, we will prepare propane using Corey-House reaction. In order to prepare propane, we need to combine one methyl and one ethyl. Remember that Methyl is provided by the Gilman's reagent, which we will learn, while ethyl is provided by the alkyl halides. Now we will prepare Gilman's reagent in two steps. We already know that we use two things, lithium and copper iodide. In the first step, I take 2 lithium, while in the second step, I take copper iodide. Now listen carefully. We need only one methyl from Gilman's reagent. So I take alkyl halide, which has one methyl like methyl bromide. In the first step, we react it with 2 lithium. Now the easy trick to crack this reaction is the lithium is electropositive and bromine is electronegative. Hence, one lithium atom will attack on this bromine to form lithium bromide. The second lithium will create a bond with CH3 to form CH3 lithium or methyl lithium. So first step is completed. In the second step, I take this methyl lithium. I write it 2 times. We know that we use copper iodide in the second step. Now lithium is electropositive and iodine is electronegative. Lithium will attack on iodine. We get lithium iodide. Now this thing and this alkyl radical is remaining. It will create a bond with copper. I write this whole thing copper lithium. Then I bond this CH3 and this CH3 to it. This compound is lithium dimethyl cuprate, which we call Gilman's reagent, because it was first created by Gilman. Thus we have successfully formed the Gilman's reagent. Now in the third step, we will combine methyl and ethyl to form a propane. I take this Gilman's reagent and I write it here. Secondly, we need methyl, so I take ethyl bromide. We know that Gilman's reagent provide methyl. So this is the methyl provided by the Gilman's reagent. Lithium is electropositive. It will attack on electronegative bromine to form lithium bromide. This ethyl is left behind. Now this methyl and this ethyl will react together to form propane. The remaining ingredient is CH3Cu. I write it here. Thus using Corey-House reaction, we successfully prepared a propane. Hence note it down. Now I will use Corey-House reaction to prepare pentane. In order to prepare pentane, we need to join ethyl and propyl. We know that ethyl is provided by the Gilman's reagent and propyl is provided by the alkyl halide. Now to form Gilman's reagent, we will follow 2 steps. In the first step, we use 2 lithiums and in the second step, we use copper iodide. We need ethyl from Gilman's reagent, so I take ethyl bromide. We know that we use 2 lithium in the first step. Now 1 lithium being electropositive attack on this electronegative bromine. I get lithium bromide. The second lithium react with CH3CH2 to form ethyl lithium. So the first step is completed. In the second step, I take this ethyl lithium. I write it here 2 times. We use copper iodide in the second step. Now this lithium being electropositive attack on this iodine, we get lithium iodide. This thing and this alkyl is remaining. It will form bond with copper. I write copper iodide. I bond this CH3 and this CH3 to it. This compound is lithium diethyl cuprate, which we call Gilman's reagent. So the second step is completed. Now in the third step, I combine ethyl and propyl to form propane. I take this Gilman's reagent and I write it here. Secondly, I write propyl bromide because I need propyl. We know that Gilman's reagent will provide this ethyl. This lithium will attack on bromine to form lithium bromide. Now this ethyl and propyl react together to form a pentane. The remaining reactants are CH3 and Cu. I write it here. Thus using a Corey-House reaction or Coley-House reaction, we successfully prepared a pentane and note it down. Now the third method to prepare alkanes from alkyl halides is reduction. We already know that reduction means gain of hydrogen. For example, consider this alkyl halide. Let I introduce two hydrogen to this alkyl halide. One hydrogen will react with this chlorine to form HCl. The second hydrogen will react with alkyl to form alkane. This alkyl halide gained hydrogen, so it is reduced. Thus we learn that if we provide two hydrogen to alkyl halide, it is reduced and we get alkane. Now the question is, how can we generate these two hydrogen to reduce alkyl halide? Well, we know that a reducing agent always produces hydrogen. For example, consider zinc plus HCl. We know that zinc is electropositive and chlorine is electronegative. Zinc will react with chlorine to form zinc chloride. This hydrogen is produced, which we call nascent hydrogen. Now to balance this reaction, I put 2 here and 2 here. Thus if we use zinc plus HCl, it will produce 2 nascent hydrogens. I put square bracket because these hydrogens are highly reactive. Therefore, I will use zinc plus HCl to reduce alkyl halide. Now consider this alkyl halide. I add zinc plus HCl to this methyl chloride. These zinc plus HCl will generate 2 nascent hydrogens. The first hydrogen will react with this chlorine to form HCl. The second hydrogen will react with this methyl to form methane. Hence, this methyl chloride is reduced to methane. Secondly, I add zinc plus HCl to ethyl chloride. Zinc plus HCl will generate 2 nascent hydrogens. The first hydrogen will react with chlorine to form HCl. The second hydrogen will react with ethyl to form ethane. Hence, this ethyl chloride is reduced to ethane. Thirdly, pause the video and convert propyl chloride to propane. Well, it is super easy. I add zinc plus HCl. It generates 2 nascent hydrogens. The first hydrogen reacts with chlorine to form HCl. The second hydrogen reacts with propyl to form propane. Thus propyl chloride is reduced to propane. Therefore remember that we use zinc plus HCl to reduce any given alkyl halide. Hence note it down. Now the last method to prepare alkane from alkyl halides is using Grignard reagent. Here, this R and G in Grignard reagent reminds me something. I say RGMX. It means Grignard reagent is RMGX, where R is alkyl group, Mg is magnesium, and X is halogen, like CH3MgCl or CH3CH2MgBr. These are known as Grignard reagents. Now to prepare alkanes, we follow 2 steps. In the first step, Grignard formation takes place. In the second